Whereas objective 3 involved absolute value, objective 4 involves quadratics, factoring and solving quadratics. Now, factoring is something that you can always get better at, so your factoring skills are going to play a huge role in how successful you are in Objective 4 and Worksheet 4. I'm reviewing basically one type of each factoring method that you see on Worksheet 4. The first one is what I just call a regular old trinomial factor. It's 3 terms. The x squared term has a leading coefficient of 1. The problem is already set equal to 0, so it's time to start factoring. We're looking for factors of positive 12 that add up to negative 7. You may have learned this with the help of a little graphic helper called the diamond method, where we put a positive 12 up there and a negative 7 down there. And what you're looking for are the two numbers that multiply to give you positive 12 and add to give you negative 7. If you don't know what I'm talking about, if you've never seen this before, that's fine. All it is a little graphing helper that some textbooks use. The numbers are negative 4 and negative 3, which means the factors of this problem are x minus 4 and x minus 3. Now we're going to set the problem equal to 0 like it's already equal to 0 right now, and make each little factor into its own equation. X minus 4 equals 0, and x minus 3 equals 0. And then solve each one of those little equations. The first one, add 4 to each side, and you get x equals 4. The second one, add 3 to each side, and you get x equals 3. The second method that we'll review in problem B is differences of perfect squares. This is a perfect squared term. This is a perfect squared term. There's a subtraction sign between the two, so you know it gets to follow the form a plus b times a minus b. In this case, it's 6x plus 5 and 6x minus 5. So do what we did before. Set each one of those factors equal to 0. 6x plus 5 equals 0. 6x minus 5 equals 0. On this first one, you would subtract 5 and then divide by 6, and x equals negative 5/6. On this one, you would add 5 to each side. So you'd have 6x equals positive 5, then divide by 6, and you'd have x equals positive 5. For problem C, the very first step to factoring is always look for a greatest common factor. I put a greatest common factor in problem C. Both of these terms share a factor of 2x. So I'm going to factor out that 2x, which means the 2x is going to be out here in front, and what's left is in the parentheses. 2x squared divided by 2x is simply x. 14x divided by 2x is 7. And there's our factored equation. Now we do what we did before. Each one of the factors is set equal to 0. In this case, the first factor is 2x, so 2x equals 0. Divide both sides by 2. X still equals 0. This one, x plus 7 equals 0. Subtract 7 from both sides, and you get x equals negative 7. Problem D is an example of factor by grouping. Now, this part of the problem has already been done for you. Both of these terms have a common factor of x plus 2. So we're going to do what we always do when we find a common factor. We're going to factor it out. So x plus 2 is the common factor. And then I call the other binomial in the problem the uncommon factor. So if x plus 2 is the common factor, then x plus 9 is the uncommon factor. Now solving each one of these, x equals negative 2, x equals negative 9. Now for problem E, a couple things about problem E that I wanted to put in the example. Notice for one thing, it doesn't equal 0. So the 14x needs to move over from the right-hand side to the left-hand side. And it has its own little rightful place in the equation. It goes between the x squared term and the constant, the term that doesn't have any x at all. So the new equation would be written 3x squared minus 14x minus 5 equals 0. Now this is the factoring technique that gives students more problems than anything else. It's a regular trinomial, but it has a leading coefficient that is not the number 1. So that has to be taken into consideration when you do your FOIL to try to make that middle term work. Now the nice thing about this is 3 is a prime number, so if you figure there's a number right here and there's a number right here, okay, this times this has to equal that because that's the first step of FOIL. So 3x times x has to be x squared. Now, the last step of FOIL is trying to get that negative 5. So something goes here and something goes here, and when you multiply those two numbers, you get negative 5. But when you do the entire FOIL, you've got to get negative 14 in the middle. Well, the only way that's going to work is if I put a minus 5 right there and a plus 1 right there. Now, if you FOIL it out, 3x times x is 3x squared. The outside terms, 3x times negative 5 is negative 15x. The inside terms, 1 times x is positive 1. So negative 15x and positive 1x combined like terms make negative 14x. Now set each factor equal to 0 and solve each factor. This one over here on the right is the quick one. X equals positive 5. Over here, takes a couple of steps, subtract 1. 3x equals negative 1, divide by 3, x equals negative 1/3. My last example for solving a quadratic is not through the use of factoring, it's through taking the square root. So in example F, you can see the equation. Now in this particular method, the problem does not have to equal 0. Anytime you're solving by a factoring method, it has to equal 0. We're just going to start doing a series of algebra steps, which includes taking the square root. But that isn't the first thing that's going to happen. The first thing that's going to happen is we're going to subtract 6 from both sides. We're just beginning the multiple step algebra method to solve this problem, which leaves me with 3 times x plus 2 quantity squared equals 36. Now the next thing I'm going to go after is that leading coefficient of 3. So I'm going to divide both sides by 3. And now I have x plus 2 quantity squared equals 12. Now is where I'm going to have to deal with this square by taking the square root. I can't go after this positive 2 until I release it from the square. So the way to reverse the effects of a square is by taking the square root. So now I'm going to square root both sides. That's the next step. square root this side, and what you do to one side, you do to the other. So the left-hand side just removes the square. So x plus 2 equals. Now on the right-hand side, a couple of things are going on. Anytime we take the square root, it's really plus and minus. So it would be plus and minus the square root of 12. But there's a simplified version of the square root 12. If you break down 12, make a little factor tree. 3 times 4, 4 is 2 times 2. There's your pair of 2's, so plus and minus 2 square root 3. Now my last step, remember the ultimate goal of this problem was to solve for x. So I really only have one more step, and that would be subtract 2 to get x by itself. But over here, where does that minus 2 actually go? X equals, it actually goes right there. X equals negative 2 plus and minus 2 square root 3. And that's your answer to that problem. Now, the last example I've got for you is not a solving problem at all. It's a simplify problem. This may look familiar. It's leading you into the quadratic formula. But in worksheet 4, we're just having you simplify a quadratic formula that has already had all the numbers substituted in. So all we have to do is, simplify this. So we've got negative 3 plus and minus 3 squared is definitely 9. Now here's the tricky part. We're going to look at that as the subtraction sign that it is, minus. Now 4 times 2 times negative 5. In the quadratic formula, if you remember the quadratic formula, it's 4 times a times c, but we're already putting 2 and negative 5 in. So 4 times a times c, 4 times 2 times negative 5. 4 times 2 is 8. 8 times negative 5 is negative 40 over 4. Now the subtraction and the negative are going to turn positive. So negative 3 plus and minus the square root of 49 all over 4. Now, the square root of 49 is a perfect square. It's 7. So negative 3 plus and minus 7 over 4. Now we're going to do what I call take the high road and the low road. The high road is going to be using the plus. Negative 3 plus 7 is 4. So 4 over 4 equals 1. So 1 is one of the solutions to this simplification. Now the other one, let's take the low road, the minus. Negative 3 minus 7 is negative 10 over 4, which simplifies down to negative 5 over 2. And that's a quick little look at all the things that are going on in Worksheet 4. And there are a lot of things going on in Worksheet 4.